Today we are going to learn about mastering k-fold cross-validation in Scikit-learn. We'll explore how to effectively implement k-fold cross-validation to enhance your machine learning model's accuracy and reliability. Welcome to our introductory block on k-fold cross-validation. This technique is a fundamental aspect of machine learning model evaluation. Unlike the traditional train test split, which can be biased and inconsistent, k-fold cross-validation provides a more robust and reliable assessment of your model's performance. By dividing your dataset into k-subsets, or folds, you systematically train and validate your model across different data splits. This not only enhances accuracy but also ensures the model's reliability across unseen data. In this session, we'll set the groundwork for understanding and implementing k-fold cross-validation using Scikit-learn. In this block, we delve into why k-fold cross-validation is often preferred over a simple train test split. First, k-fold cross-validation minimizes bias by ensuring that each data point has the chance to be in a training and test set. This method improves the reliability of your model's performance metrics by providing a more comprehensive evaluation. Another crucial advantage is that it utilizes the entire dataset, ensuring that your model learns from all available data. This leads to more robust performance metrics and minimizes the risk of overfitting. Unlike a single train test split, which can be heavily dependent on how the data is divided, k-fold cross-validation provides a more stable and reliable assessment. Now, let's explore how to implement k-fold cross-validation in Scikit-learn. Scikit-learn, a popular machine learning library in Python, offers a straightforward way to apply this technique. The primary function used is cross_val_score. This function requires key parameters, the estimator, the dataset, and the number of folds. We'll walk through a simple code demonstration to show how you can set these parameters and execute the function. Understanding the output is crucial, as it provides insight into the performance of your model across different folds. By the end of this block, you'll be equipped with the knowledge to implement k-fold cross-validation in your own projects. Choosing the right number of folds, represented by k, is crucial in k-fold cross-validation. The number of folds can significantly impact the performance and reliability of your model. A smaller k can lead to higher bias, while a larger k can reduce bias but increase variance. Typically, common choices for k are 5 or 10, balancing the trade-off between bias and variance effectively. However, the optimal number of folds may vary depending on the dataset size and the computational resources available. We'll discuss practical considerations and strategies for experimentation to help you make an informed decision about the number of folds for your specific use case. Imbalanced datasets pose a significant challenge in machine learning, as they can skew the results of model evaluation. In this block, we will explore how k-fold cross-validation can be adapted to handle such datasets effectively. Imbalance can lead to biased evaluation metrics, often resulting in models that perform well on the majority class but poorly on the minority class. One strategy to address this is using stratified k-fold cross-validation, which ensures that each fold maintains the same class distribution as the entire dataset. We'll also discuss other practical tips and examples to manage imbalance, ensuring a fair and accurate evaluation of your model. Stratification is a vital technique when dealing with imbalanced datasets. It ensures that each fold in the k-fold cross-validation process maintains the same class distribution as the overall dataset. In Scikit-learn, this can be easily implemented using stratified fold. This ensures that your model's performance is evaluated more accurately, reflecting real-world scenarios where class imbalance often exists. The benefits of stratified k-fold include more reliable performance metrics and a better understanding of how the model handles different classes. However, it's important to be aware of limitations, such as increased computational requirements. We'll provide a detailed look at how to implement and benefit from stratification in your projects. While k-fold cross-validation is a powerful tool, there are common pitfalls that users should be aware of. One major risk is overfitting, where the model performs well on the training data but poorly on unseen data. Data leakage is another critical issue, which occurs when information from the test data leaks into the training process, leading to overly optimistic performance metrics. Misinterpretation of cross-validation results can also lead to misguided decisions. Choosing an inappropriate number of folds, or k, can further complicate model evaluation. Lastly, a lack of thorough cross-validation can result in unreliable model assessments. We'll discuss these pitfalls in detail and provide strategies to avoid them, ensuring you can effectively apply k-fold cross-validation in your machine learning projects.
To solidify our understanding, we'll walk through a practical example using a real dataset. We'll begin with an overview of the dataset, highlighting its characteristics and challenges. Next, we'll guide you through a step-by-step implementation of k-fold cross-validation using Scikit-learn, covering everything from data preparation to executing the cross-validation process. Analyzing the results will provide insights into the model's performance and areas for improvement. Finally, we'll discuss how these insights can be applied to enhance model performance in real-world applications. This practical example will equip you with the skills needed to apply k-fold cross-validation to your own datasets effectively. As we conclude our video, let's recap the key takeaways from mastering k-fold cross-validation in Scikit-learn. We've highlighted the advantages of k-fold over a simple train test split, provided step-by-step guidance for implementation, and discussed the importance of choosing the right number of folds. We've also covered strategies for handling imbalanced datasets using stratification and shared insights on avoiding common pitfalls. Most importantly, we've demonstrated practical application using a real dataset, equipping you with the skills needed to enhance your machine learning models. Thank you for watching, and we hope this empowers you to apply K-fold cross-validation effectively in your projects.